Okay, so yesterday Codeforces round 672 division 2, there was a problem C1 Pokemon Army, the easy version of it. So let us read the problem first. If you have not solved it, let's just read it once again actually. There are n Pikachu Pokemon. The strength of the ith Pokemon is equal to A of I. All numbers are distinct. We have to choose a non-empty subsequence. Okay, and how should we choose the non-empty subsequence? We have to maximize the alternating sum of the elements. Alternating sum means first minus second plus third minus fourth, like that. And in the easy version, we don't have to swap any Pokemon. We just have to print maximal strength of the army. So we have to choose a subsequence such that this alternating sum is maximum. Actually, if you think it is dynamic programming, yeah, it is easily solvable. But I want to give another approach for this. It is almost the same kind of thinking only, just that maybe you can call it greedy. Just look at my solution and tell me in the comments what do you think. So this is what I would do instead of going for DP. Let us take the third test case over here. They have explained not so nicely, but you will get some idea when you look at this. Why they have highlighted this 5, then 3, then 7. Why is that? As you can see, until 5, okay, until 5, all the numbers are increasing. After 5, 4, 4 and 3. So after 5, it is decreasing. So what I will do is, when I have to pick every odd element, that is, if I have to pick the first, third, fifth element, what I will do, I will go on uh, checking until when the element I am considering is greater than its neighbor. I'll repeat that once again. When I have to take any odd element of the sequence, odd element matlab like first element, third element, fifth element of the subsequence that I'm considering, if I have to take any odd element, then I will only consider that one which is greater than its neighbor, the right side. Until then, I won't do anything. That means it is increasing over here, right? 1, 2, 5, let it increase. As soon as it drops, I will take that element. So this is for odd element. Now for even element like A2, sorry, the second element, fourth element, as you can see, we are subtracting the even element from the odd element and adding their sum. So if this value is small, this minus this will be large. If this value is small over here, the second element is small, first minus second will become large. I hope you can understand this much. So with that logic, what I will do, whenever I have to consider an even element, I will consider that element which is less than its right neighbor. That means now I will let the array decrease, and then whenever it again increases, I will take that. Let me explain this to you with a better, I think I can draw a graph also and show you. It will be a better approach. So the array is 1, 2, 5, 4, 3, 6, 7. Okay. Now let us see how the array is. First it is 1, okay, then it is 2, okay, then it is 5, then it became 4. So it was increasing, then it decreased. Since I am considering for the first element, that is the odd element, I will take 5. So I will take 5, okay. Now 4, then it became 3, then it suddenly became 6. since I'm considering the second element, I want it to be smallest. I want it to be least. That is why I will take 3. Now what to do? Now there is one element left, which is 7. I should include that element. When should I always include that element? I should include the last element when the size of the vector is odd. Sorry, when the size of the vector is even. Size of which vector? Size of this vector represents what? The subsequence. When the subsequence has even number of elements, that time I can consider the last element, because when I'm considering the last element, I will have odd number of elements. At that time, I will have odd number of elements. So it is going to be something like, in this example, if I consider 5, 3, 7, 5 minus 3 plus 7. That's all. So whenever we have selected a subsequence having even number of elements, we will then also include the last element, because then our sum will increase. If suppose the subsequence was already this, okay, if it was already something like this, then should we consider the last element? If the subsequence has odd elements, we will not consider this last element. We will not say minus 7, because we are subtracting, which will reduce the sum. So in this approach, when we are finding out the subsequence, when the subsequence we get has even size, then only we will consider the last element. Otherwise, we will not consider the last element. That is what I have done here. When we are considering the subsequence, if it has an even size, then I will consider the last element. And then I am simply calculating the sum. So it is just observing the array. It is increasing first, then decreasing. So take the element which is the maximum, and then minimum, then maximum, then minimum, maximum, minimum, like that. And important condition is this only: when the subsequence that you have already selected has even number of elements, also if the last element is not considered, you should consider that also. So if it has an odd length, don't consider. If it has even length, consider it. So this was the approach to the problem. I will attach the solution. You can go through. I will put it in the description. So the approach was to take maximum. It is like local maxima, local minima. If I have to summarize what I'm telling, it is somewhat similar to local maxima and local minima. Some kind of something similar, not exactly that only, but the thinking is this only. So this is how you can approach the problem. That's all for this video. I hope you could understand what I was trying to say. And please share the video and subscribe. Thank you for watching. Bye.